Hello, 7th graders. We're going to talk a little bit about how to solve equations that involve more than one step. So far we've talked about just one-step equations where you just had to do one step to get your variable by itself. So maybe the original equation had addition and you had to subtract to get x by itself. Maybe the original equation had multiplication and you used division to get x by itself. So now we're going to start looking at some equations that have multiple steps in them and the order that those steps need to be taken. So one thing that we want to be remembering is what the object of an equation is. So when I say the object of an equation, it means our goal of every equation, and that's to figure out what the variable represents. We're constantly trying, that's our ultimate goal. We want to know, what does the variable represent? So before we talk about equations, we're going to actually just do a little gift wrapping 101. So if we were to wrap something, all right, there might be a series of steps involved there. So our first step might be to put it in a box and then wrap it with some paper. And then maybe the last step is we stick on a sparkly bow. Okay, so then let's think about the steps to unwrapping that present. All right, and we're going to pretend that like you're a really neat person when you unwrap a gift. So we're going to do all those same steps, but in reverse. So the first step that we would do is we're going to unstick that sparkly bow, and then we're going to unwrap the paper, and then we're going to take it out of the box. So when we think about solving an equation that has more than one step, we are going to focus on this unwrapping. We did all of the same steps, but we undid them in the opposite order. Okay, so if you look, the last thing I did here was I stuck on the sparkly bow, and the first thing I did was unstick that sparkly bow. My second step had been to wrap with paper. My second step here was to unwrap it. And then my first step was to put it in the box, and my last step here is to take it out of the box. So again, we're doing all of those same, we're undoing those steps in the opposite order. So we have a little story time here. All right. Once upon a time, x was alone on one side of the equation. So over here, we have x by himself. And right now that we have 3 is equal to x, or 3 has the same value as x. So we multiplied both sides by 2. So when I multiply x times 2, I get 2x. And when I multiply 3 times 2, I get 6. And then we added 1 to both sides. So over here, 1 and 6 are like terms. They're both constants. So I get 7. Over here, 2x plus 1, those are not like terms, so I have to leave it as 2x plus 1. So I ended up with this equation, 7 is equal to 2x plus 1. So when we talk about solving that, we want to unwrap the equation. All right, I want to undo all of those steps, but in the opposite order. So the last step was adding 1. So then the very first thing that I'm going to do is I need to subtract 1 from both sides of my equation, okay? And so when I do that, this positive 1 and that negative 1, or the positive 1 subtracting 1, whichever way you want to think about it, those zero out. Now with the 1 steps, that just got us x by itself. But now I still have the 2x left. And then on the left-hand side here, 7 minus 1 is going to give me 6. So now I have 6 is equal to 2x. So now I'm going to ask myself, what's happening to my variable? Well, it's being multiplied by 2. So now this is where I would divide both sides by 2. Over here, I'm going to see that 2 divided by 2 is equal to 1 whole. So I have x by itself. And 6 divided by 2 is equal to 3. So we're going to undo those steps, but in the opposite order. So let's look at this example. We have negative 5x plus 12 is equal to negative 3. If you have a hard time figuring out what you need to undo first, one strategy, I guess, would be kind of like highlight or cover up where the variable is. So right now when I do that, I see that the x is most closely tied with that negative 5. So that means that was the first thing that happened to it, okay? When this equation was built, x was multiplied by negative 5, and then we added 12 to get negative 3. So I need to undo that in the opposite order. So because the x is most closely tied with -5, that means I can't touch that until I get rid of or undo this plus 12. So how do I undo adding 12? I need to subtract 12. Golden rule of equations is whatever you do to one side, you do to the other. So when I subtract 12 on the left over here, those 12s will zero out. That positive 12 and the negative 12 zero out. But again, I'm not left with x by itself. X is still with that -5. So I have -5x. And then on the right-hand side, I have -3 and -12, which is going to give me -15. So now I'm going to ask myself, okay, what's happening to my variable? So here's my variable. X is being multiplied by -5. I need to undo that. To undo multiplying, I'm going to divide both sides by -5. Over here, -5x divided by -5 will equal 1x. So I have x by itself now. And -15 divided by -5 will equal +3. So x is going to equal +3 there. I'm going to look at another example. So here I have -15 has the same value as w divided by 2 minus 8. And so when I look at this, I want to think, okay, where's my variable and what's most closely tied with it? That would be the first thing that had happened to that variable. But again, we want to go in the opposite order. I need to unwrap my equation. So since the w was first divided by 2 and then I subtracted 8, I need to undo that subtracting 8 first. So to undo subtracting 8, we're going to add 8 to both sides. So that -8 or -8 and +8 zero out. So now I'm just left with w divided by 2. And then on the left-hand side, -15 plus 8 is going to give me -7. So now I'm going to ask myself, what's happening to my variable? Well, w is being divided by 2, so now I need to multiply both sides by 2. 2 times -7 will give me -14. And over here, the 2's, what ends up happening is I have 2w divided by 2, and my 2's will 1 out, leaving me with w. So w is equal to -14. And again, we can always check our answer, because if I plug in -14 for w, then I should, and evaluate this side of my equation, I should get -15. So if I do -14 divided by 2 and then -8, I should get -15. So -14 divided by 2 is -7. -7 minus 8 does indeed actually equal -15. Just a couple of other ones to look at that might be a little different than your traditional equations. Here we have 3m plus 5m is equal to 32. So one thing we want to do that we really haven't had to do before is we want to always make sure that the side of the equation with the variable is in simplest form. So if it's an algebraic expression, there's no parentheses and there's no like terms. So when I look here, 3m plus 5m, well, those two things are like terms. So I can go ahead and combine those m's together. So 3m plus 5m actually give me 8m. And so now I have 8m is equal to 32. And then now it's become that one-step equation. So what's happening to my variable? M is being multiplied by 8. So I want to undo that by dividing both sides by 8. Over here, my 8's will 1 out, leaving me with 1. And then 32 divided by 8 will equal 4. So M would equal 4. And we're going to look at these two spicy problems as well, just really quickly. So we want to look at where our variable is. And so right now, think of that as being locked in with your variable. You can't touch it until you undo the other things. So here, my k is locked in with 2/3, so I can't touch that until I undo the -5. So to undo -5, I'm going to add 5 to both sides. My 5's will 0 out, so now I'm left with 2/3 k is equal to 15. Well, I know to undo this 2/3 k, I can multiply by the reciprocal of 2/3, which is 3/2. So remember, if we wanted to divide by 2/3, that's what we're doing. But when we divide by a fraction, it's the same as multiplying by the reciprocal. So on the right-hand side, 3 times 2 gives me 6, 2 times 3 gives me 6, and 6 over 6k is going to, the 6 is 1 out to leave me with k. Whatever I do to one side, I need to do to the other. So I'm going to multiply this left-hand side by 3 over 2. It's a little squished, sorry. 3 times 15 will equal 45. 2 times 1 gives me 2. And 45 divided by 2 is going to be 22.5. Or 22.5 would be another acceptable answer there. So k would equal 22.5. All right, and then one last multi-step equation. We have 3 times the quantity a minus 5 equal to 114. So this is a good example of, right now that the variable, the first thing that happened to it here was we subtracted 5 and then we multiplied by 3. So this one you could actually solve a couple of different ways. You could either simplify the left-hand side with the variable first by distributing the 3. And if you distribute that out and multiply, and then you would have a 2-step equation. Another way is this 3 is actually being multiplied by the a minus 5. So to undo multiplying, I could divide both sides by 3. So over here, the 3's will end up 1ing out. When I say 1 out, that means 3 divided by 3 equals 1, okay? And so now I'm left with a minus 5. And when I do 114 divided by 3, I'm going to get 38, I believe. 90, 24. Yes. And then, so now I have a minus 5 is equal to 38. So what's happening to my variable? I'm subtracting 5. So I need to undo that by adding 5. 38 plus 5 will give me 43. So a would equal 43. One other way you could solve that same equation, so I'm going to actually write that over here. So if I had simplified this expression first with the parentheses and cleared the parentheses by distributing, 3 times a would be 3a, 3 times negative 5 would be negative 15, and then would equal 114. So now my variable is locked in with that 3. And so the first thing I would need to do is undo the minus 15 by adding 15. So now I have 129 and 3a, and then now I divide by 3, and then I'll still end up with 43. So this one you actually have 2 different ways that you can go about solving that equation. All right, that's a little bit about solving some multi-step equations. Hopefully that helped. Have a great day.